So I have an interesting question for you, and then perhaps I can expand on my experience as well. So what was your sort of first exposure to programming, and sort of at what point did you realize that that you think doing computational research would be a good fit for you?
I interviewed with two professors,
So
basically.
this
I
is
think
fourth year. This is fourth year.
my fourth year
Just to make
under.
this clear. Okay. Okay.
Yeah. So my last year of undergrad, I had done both of the computational physics courses at Waterloo, which ostensibly teach you Python and C. And I learned almost nothing from the C++ course, I have to confess to you, but I had it on my CV nonetheless. And so I applied to McMaster and I interviewed with two professors. One of them worked in the analytics side of things, and the other the computational side of things. And the person who did the computational side of things had funding. I ended up working with them, and we so then that first summer I was here, I basically from the ground up sort of taught myself the ins and outs of C and C++, which I
Which
love.
just a shout out. I would say that I'm competent at C++, but I certainly do not compare to James's sort of
Oh, that's very
skill
flattering.
and knowledge of the language. He's an excellent programmer.
That's a very generous thing to say. I really love programming. It's a great joy, I think, of grad school for me that I've had an opportunity to hone that skill. But I also fell into the trap early on of being really disparaged from embracing my numerical side by these sort of arrogant analytical physicists. And so I now have a sort of smattering of papers. I've got some papers where I do numerical techniques and other papers where I've done analytical techniques, and sort of play with both of these things. And I think for me at core level, what I'm really excited about is the answer to the question I'm curious about at the moment. So whether I have to do a numerical method or work on some analytical technique to get that answer, although I'd be kidding myself if I tried to pretend that I was anything like as competent as the analytical folks are at their techniques. I'm definitely much more competent and experienced working with numerical methods than with analytical methods. Yeah, but I think it was really sort of something where you just kind of, you know so little as an undergrad. I knew so little as an undergrad, and I think this speaks for a lot of people's experience. You know so little about what the field looks like, what it looks like to really work on these problems all day long,
Yeah.
what techniques you're going to use. And so whatever prejudices you might have about what you're going to like and what you're not going to like, I think very often are going to be upended by the real experience when you're actually, so, for example, I had a friend of ours who started off as a colleague of mine directly working in the same research group, sort of on the numerical side of things, really desperately wanted to work with this professor who does analytical techniques, and actually sort of camped outside of his office, and just with great determination and zeal was able to get a position with this research group doing analytical work, and has been doing that now for several years. And I think now is contemplating going back into the numerical side of things, maybe doing artificial intelligence work, because I think that they found that particular flavor of analytical work just really didn't click for them. And so I think that's something that, I don't think that it was a mistake for that person to do that. I think that you should dive into the thing you're interested in, try it out, and it's okay not to stick with it forever.
Yeah.
Life is about learning and trying new things, and I think that's perfectly reasonable. But I think we shouldn't be so hard on ourselves. If we go in for one set of techniques and we find that the thing we thought we really wanted to do just wasn't for us, there's no shame in that. There's nothing wrong with trying some new technique, trying some new set of methods. I think, in fact, I think that actually makes you a much more well-rounded researcher, because you can just talk to more people, you can understand more results, you can see where your work fits in with the bigger ecosystem, all the better for trying out a few different techniques. And your PhD really is the time to do that.